Yes, oui, ça marchait nickel ce matin.
Ah non, j'ai un live. C'est bon, j'ai un live.
Ouais, c'est bon. Ouais,
Ça fonctionne?
ouais, c'est bon, ça marche. Je peux remettre en partage et tout.
Il faut garder cette site?
Laisse la page ouverte, mais tu peux.
Ça fonctionne?
Ouais, tu peux repartager.
Oh, il y a un beau lag.
Oui, il y a.
On voit le stream setting, on voit les bookmarks. C'est pas le logo de. C'était juste un signe distinctif. On va le voir.
Pardon?
Ah. Fais un test micro.
Ah. 1, 2, test, test.
Ah, tu vois.
Ah oui, mais c'est moi.
Il y a 3-4 secondes de latence.
C'est juste qu'il n'y a pas de son sur
Il y a une nouvelle machine qui ne marche pas.
Et si je fais comme ça, il est toujours bien l'écran? Parfait.
T'as toujours le sac qui déconne, il faut juste le décaler un peu.
J'ai déjà.
Ah, mais en fait, il faut que j'arrive à arriver à.
On peut arrêter le partage?
Non, non, parce qu'en fait, dès que tu arrêtes le partage, ça le change.
C'est bien. C'est déjà bien.
Voilà. Pourquoi? Ah oui, c'est ce qu'on t'en confirme.
C'est ça. Ouais, je viens de voir la.
En fait, c'est le jeu.
Je viens de voir la fenêtre, c'est lequel.
De niquer la bande
La
passante.
bande passante pour vos ex.
Eh, il y a 12 abonnés quand même. Hein.
YouTube. Ah, c'est comme avant. Parce que avant, je suis d'accord. Ah oui, donc le jeu, c'est que. Non, stylé ça. La semaine. Et toi, voilà, tu pourras rajouter sur le
Bien. Par curiosité.
Oui, si tu sais.
Non, c'est pour moi.
Mais oui, c'est pour parler, tu parles.
Ça me fait plaisir.
C'est fou. Ah ouais.
Non, 60 sur la mais là, comme tu vois, c'était vraiment saccadé.
Oui, 8.
5.
Pardon, je sais pas. Tu peux diffuser. Oui. Attention, hein, si tu diffuses un truc copyrighté, je fais pas YouTube. Ah oui, c'est clair. Ah oui, oui, qui tombe. Ah mince, c'est direct.
Yes.
So the jury in person, they are here now. So I will give the floor to Fabrice yeah, please.
Carla, Javi, and Nathalie, good afternoon. I have one question. Do you have any...
Cette réunion est en cours d'enregistrement.
Bien joué. I have one question. Do you have any time constraints today, this afternoon?
I have a commitment at 6 p.m.
Okay, nice. Nathalie?
16 for me, 5:30.
Okay, 5:30. Okay, it's okay.
And me at 5:45, so it's okay.
J'espère qu'on va finir avant.
Il est parti.
Ah non, je suis là.
Okay, so good afternoon, everyone. So we'll start the defense of Georgios Papadopoulos for the habilitation à diriger des recherches. I don't know the translation, I'm sorry. From University of Rennes 1. So before to start your presentation, I introduce your committee. First, I start with the reviewer. You have 3 reviewers. I start in the order of your slides. So first, you have Nathalie Mitton, which is research director at INRIA, Lille Nord Europe in France. Then Carla Fabiana Treccherini, which is professor at Polytechnical University of Torino in Italy. Javier Villarosana Guillen, professor at Open University of Catalonia, Spain. So for the 3 reviewers. And from the examiners, we are 4. I start with Martin Heus, who is professor at Grenoble BNP, France. Then you have César Villot, who is professor at University of Rennes 1, and Marcelo Diaz d'Amorim, research director at Soutenance, France. And myself, I am Fabrice Valois from INSA. Georgios, you have 45 minutes, 45, sorry, for your presentation. And then, after your presentation, I will manage the time. We'll have discussion and questions with the reviewers, and then with the examiner. Okay, let's go.
Thank you so much, Mr. President. Good afternoon and welcome all to my HDR defense presentation. Thank you all for being here. I would like to give special thanks to the 3 reviewers, Nathalie Mitton, Carla Fabiana Treccherini, and Xavi Villarosana for reviewing my manuscript and for their encouraging report. Excuse me for this. I would like also to thank you, the 4 members of the jury, the examiners. Thank you so much for coming here. It's considering the circumstances, I really appreciate for you being here. Today I'm going to present my HDR manuscript entitled Reliable and Available Low Power Wireless Mesh Networks. And it is the result of the hard work of the last 5 to 6 years. So after my PhD thesis, I went to the University of Bristol, where I worked as a postdoc, beginning of 2016. I joined the University of Bristol, where I had my main task was to be a coordinator of a European project, FP7, from the Bristol side. Then, during the same year, I got the permanent position as an associate professor at the time, Telecom Bretagne, today is EMT Atlantique. And after several years of intensive period of writing the research projects, We got some luck and we got accepted projects, both all from the city scale grants, from regional grants, and from the national, the well-known ANR JCJC for young researchers, which gave us the fundings to be able to recruit several PhD students, a postdoc fellow for 3 years, and many research interns. We continued doing this process of writing intensively the research projects to get more fundings and to be able to stay always at the state of the art of the research, and so to anticipate for the upcoming years to always be able to have the PhD students, postdocs, and research interns. Since 2021, in February, I joined for 10% of my time the Research Institute BICOM, where I work with great people on integrated access and backhaul for 5Gs. During these years, I had the opportunity to work on different research subjects, such as fault-tolerant delay wireless networks, wireless battery management system, LoRa and LoRaWAN for routing, massive IoT, even for moving target defense in terms of security. But among all these subjects, for my HDR manuscript, I decided to focus on reliable and available wireless mesh networks. So this is the outline of my presentation for today. I will start with a positioning section. Then I will present you the research approaches that I took during my 5 to 6 years after my PhD. Then I will finish this talk with presenting you the ongoing work and the perspectives for the upcoming years. So I will proceed now with the positioning section, where I will present you the overview of the low power and wireless mesh networks. So after many decades of research and development, the wireless networks have evolved to low power wireless mesh networks, in which smart, uniquely identifiable, and wirelessly connected objects, such as sensors and actuators, cooperatively construct what is called the mesh network of things, and commonly known as the Internet of Things. Now, most of the times they come with limited capacity in terms of memory storage, computational power, and energy. Now, these last 5 to 6 years, we have been working intensively on enabling reliable and available low-power wireless mesh networks, and I'm going to present you what does it mean. So the objective of such a network is to guarantee that the transported information will be carried out in a predefined and constant delay, whatever the link quality or the congestion in the network. So the most important feature in such a network, in addition to very high PDR performance, is to have minimum jitter performance. Now, to do so, it will support the following 2 features. First, we have the reliability, where the packet is expected to be delivered at the destination within a bounded latency, and a failure when the packet is delivered lately or it never delivered. So the second feature here is the availability, where the paths in the mesh network must operate in a stated condition. Of course, nothing comes for free. In order to achieve these objectives, we have to pay the cost. And in our case here is the network capacity and the energy consumption. However, the applications that we are targeting, typically the industrial use cases, the devices in such scenarios come usually plugged into power supply, while the applications come with very low traffic rate. To conclude, the objective of our research was to design and develop a network that one can count on. Now, a typical example that I like to give during my lectures from the real-world examples is the bus analogy. Now, the goal of the reserved bus lanes in the city is to avoid that the bus will be delayed by the traffic jam, and that it will guarantee a good and repeatable experience to the passengers. Now, to do so, we have always a schedule that, a precise schedule that indicates at what time the buses will start and at what time the bus will stop at each bus stop so that the passenger will be on time to take the bus until their destination. Now, a similar approach we are looking for at the low-power wireless mesh networks. And to do so, I will show you the stack on which we are working on. So here is the typical 6-tish protocol. And we call it 6-tish because we have the adaptation layer at the 6 stop that allows us to reserve the resources. In this case is the cells that consist of time and the channel offsets we are going to see right after, in order to be able to do efficiently the communication between the nodes. Now, among all these protocols from this stack, for my manuscript, for the HDR manuscript, I have been working at the routing layer with the Ripple protocol, at the resource allocation with the 6P and MSF protocols, and at the medium access control protocol with the TSCH MAC protocol. Today, due to time constraint, I will show you the two layers, the routing and the medium access control contributions that I did. Now, in 2016, the IEEE 815.4 protocol was published, the standard was published, and among the medium access protocols that were defined in the standard is the TSCH protocol, time-slotted channel hopping, where the objective was, and it is, to give certain level of quality of service to the low-power wireless mesh networks. Now, this protocol, the standard, comes with 16 radio channels operating at 2.4 gigahertz, where each radio channel has a bandwidth of 2 megahertz and channel separation between the radio channels of 5 megahertz. So there are two main principles in TSCH. We have the part of time slotted, where the continuous time is divided into time slots of equal length. Now, a pair of devices, transmitter and the receiver, will be assigned of time slots for the communication purposes. In each time slot, we have enough time for the transmitter to send the packet, the frame, and for the receiver to acknowledge this frame. Now, a group of time slots will form a slot frame, which will be repeating during the whole duration of the experiment. The second feature of TSCH is the channel hopping part, where the nodes, they are transmitting their subsequent frames over different radio channels. Moreover, it allows for two distinct sources to send their frames in the same time to two distinct destinations, which eventually increases the network capacity since we may have multiple communication at the same time. Now, to do so, we have a second axis in this protocol, and it's called the channel offset, which is used by the nodes to calculate the radio channel over which they will send the frame. Now, this is the only equation that I'm going to show you during my HDR, and I hope I will be able to give you to understand. So we have the ASN, the absolute sequence number, which is the time that calculates in integer the time of the network. The channel offset, the 16 integer values based on which we are going to translate this channel offset into a physical radio channel, and the total number of actual radio channels. So we have 3 parameters in order to get the actual radio channel. Now, regarding the schedule, in TSCH network, all nodes follow a common communication schedule. A schedule, it is a matrix of cells that consists of time slots, so x-axis, and channel offsets, the y-axis. We can have either shared, meaning contention-based time slots or cells, or dedicated contention-free cells within the schedule. The allocation of the cells in the radio links can be done either in distributed manner with the 6P and the MSF protocols, or in a centralized, where we have a centralized entity, typically the path computation element, that will calculate and will distribute the resources among the devices. Therefore, both from the academic and from the industrial societies, a lot of focus has been given to efficiently design a schedule while guaranteeing the following 4 performances, metric performances: network capacity, bounded latency, network reliability and energy consumption. Now, a typical trade-off for industrial scenarios will be to target for high network reliability and bounded latency at the cost for network capacity and energy consumption. Finally, regarding the routing protocol, in order to extend the network beyond the radio coverage of one node, it will require a routing protocol. Now, Ripple is one of the most adopted routing protocols for industrial or for low-power wireless mesh networks, and it is defined as a link layer agnostic, meaning that we can use the Ripple protocol over wired or wireless technologies. Moreover, it is a proactive routing protocol, meaning that the paths in the network are built independently on the traffic plane, on data traffic. The nodes running Ripple routing protocol construct what is called destination-oriented directed acyclic graph, or DODAG, based on a distance vector technique. And in each DODAG, there is a single node considered to be the border router. It's called DODAG root, and which serves as a gateway for other non-Ripple-based networks. Based on common objective function, each node selects one or more parents in the network, or in the DODAG network. And finally, we have the concept of rank that defines the node's position in regard to the DODAG root. So the further is a device, the higher value will be the rank value. Now, regarding the approach that we employed in our research, we always start with the traditional approach, meaning we have the analysis, the simulation, and the experiments. Typically, we do the simulations either with the 60s simulator or with the CUJA emulator. And regarding the experiments, we usually use the open mode devices with either OpenWSN operating system or with the Contiki OS, and quite often we do some experiments over the FITA ID Lab platform. If it's possible, we try to push our solutions for standardization at the IETF standardization community, and to do so, we follow quite actively the following working groups. Next, we constantly develop and maintain testbeds in our campus for potentially obtain more realistic results. Here we have few examples of the open source vehicle, the battery of the Renault Fluence, where we are doing the experiments. And we have now our two new testbeds with the solar panels and with the electrical vehicles, and we hope that we'll soon do some experiments here as well. Finally, if it's possible again, we try to go for more realistic applications, if it's possible. So a typical work that we are working since 2017 is the wireless BMS, together with our industrial partners, the Texas Instrument and Renault. So an example that I like always to give for our research is that we start with simple testbeds done at the desk, and step by step we add our complexity and things are working. We are trying to be as close as possible to the realistic scenarios. Now I will proceed with my first scientific contribution at the MAC layer. So here we are at the protocol stack. We are at the MAC layer, and we are going to focus at the TSCH protocol. But before going to the contribution part, I would like to show you the problem formulation that we were working on to address some solutions. So, the continuous growth of wireless technologies that operate over the 2.4 gigahertz, such as Wi-Fi, Bluetooth Low Energy, or Zigbee, results in large concentration of wireless devices in the same area, causing thus intra- and inter-technology interference. In particular, we have the Wi-Fi or the 802.11 networks that represent a significant threat to the technologies such as Zigbee or BLE systems. Why? Because they're coming with higher transmission power and with massive spectrum occupancy. So therefore, we studied whether or not applying radio channel blacklisting on top of TSCH will mitigate the problems of external interference and multipath fading. Now, the question is, what is a blacklisting technique? First, the idea is to detect the poorly performed radio channels. For instance, the radio channels that perform below 50% of PDR can be any other metric, any other threshold, fixed or adaptive. And the idea is to perform a channel hopping operation without employing these poorly performed radio channels. As simple as that. Of course, there is no such a thing as a free lunch, meaning that we have to pay the cost. So the more we blacklist the radio channels, the less parallel communication we have, meaning that we reduce the performance in terms of network capacity. Now, in order to further motivate whether or not blacklisting approach it is relevant in channel hopping technologies, we did series of experiments at the FITA IoT Lab platform, and more specifically in Grenoble, remotely of course, where many Wi-Fi access points are deployed, so which means that our low power wireless mesh devices are subjected to the interference from the Wi-Fi access points. So the first figure you see here, on the left axis, on the right axis, you have the average packet delivery ratio, PDR. And on the x-axis, you have the distance. So we did multiple experiments of the transmitter and the receiver, more than 200 experiments actually. And we grouped these experiments into distances. And we classified them. And we saw that our results demonstrate that there is distance-dependent feature, meaning that the shorter are the links, meaning the shorter transmitter and the receiver are located, the better or the higher quality performance we have. So you see the higher is the blue, meaning we have better network reliability performance. Vice versa, the further are the two devices located, the transmitter and the receiver. As you can see, it's straightforward that we have more dynamic behavior in the network. Next, we have here a heat map figure, where on the left y-axis we have the 16 radio channels. On the right y-axis I have again average PDR, packet delivery ratio. And on the x-axis you see the 6 corridors of the Grenoble side, A, B, C, D, E, F. So here the idea is that the stronger is the purple color, the worse is the performance, and the lighter is the purple color. It means that the PDR performance presents better behavior. So our results here demonstrate that we have rather location dependent, meaning that, for instance, the radio channel 22 performs almost everywhere poorly. So independently where the transmitter and the receiver are located, we do have quite bad performance, while on the contrary, with the radio channel 12, we do have some corridors where we have good performance, here the green parts, and we do have some corridors, typically the corridor C and F, where you can see that the performance of this radio channel drops. So the takeaway from this work was that it is not the best idea to globally, for the whole network, blacklist a specific radio channel. Next, we selected a specific experiment. So we have the transmitter and the receiver in distance of 9 meters, and we run an experiment of 24 hours. So again, on the one side, I have the average PDR, so packet delivery ratio. On the other side, you see the label here of the 16 radio channels, while on the x-axis, you have the time of 24 hours. Now, as you can observe, some of the radio channels perform always good. So during the whole day, for instance, the channel 26 performs quite good, almost 100%. On the contrary, we do have some radio channels that they perform independently the time always bad. So it is considered that, yes, you can blacklist this radio channel, but we do have some radio channels that they are rather dynamic, meaning that during the evening, for instance, they perform quite poorly, which is a good indication for us to blacklist it. while there are some hours during the day that perform somehow good, so we may whitelist this radio channel for a few hours. So the takeaway from this experiment was that we should go rather for adaptive dynamic approach when we are considering doing blacklisting. Now, regarding the blacklisting technique, we did a series of proposals. I will show you today 2 of them. So first we have a distributed strategy where the devices, the child and the parent, the transmitter and the receiver, they constantly evaluate their radio link qualities based on, again, for instance here, PDR metric, can be RSSI, LQI, any metric. And the child and the parent, they exchange their whitelist, meaning once the child, it's found which out of these 16 radio channels are good for him, based on the acknowledgement, he will exchange through the, what we call 6P control packet. This is the 6-ish protocol, the list of the whitelist. So it means the channel hopping sequence. However, if we are going for such distributed approach, it is quite possible that 2 or more radio links that are scheduled at the same time slot. So here I have the topology on the left. Here I have the schedule, and here I have the index. So I will try to explain this example. So that if 2 or more radio links are scheduled at the same time slot, even with different channel offsets, so here we have the links CD and the EF, that they are scheduled over different channel offsets, 0 and 1, they may collide if they do not have the same channel hopping sequence. So this is the channel hopping sequence. So the index, I will show you the example here. So meaning that if we are taking again back the equation that I presented you in the very beginning, so we have the ASN channel offset and the modulo of number of channels. So this is the lookup table from the F. Lookup table means I will have either the result 0, 1, 2, 3, and we'll have lookup table which matches to the actual radio channel. So in this case, I have the 2 links CD and EF, and let's assume that we are in the experiment time ASN equal 42. As you can see, we have 2 different channel offset, 0 and 1, allocated by the scheduler. And the function gives us as an index of F2 and 3. So we have 2 and 3 in the index. And if we go now outside of this equation to the F, which is the lookup table, we can see that both of them give us the same radio channel. So to solve such a problem, we went for other strategies. We thought about a centralized strategy where the idea was to use a greedy reordering process where we will adapt these channel hopping sequences. If we have common radio channels, we will put them, as if it's possible, to the same column. And if we are missing some of them, we will add HDR. And the idea is that if you do, again, the same operation of this function, you will see that, again, 2 and 3 now will give us 2 different radio channels, 11 and 14. I will show you some performance evaluation results in terms of the blacklisting. So regarding the labels, again, I have here the packet delivery ratio, meaning the PDR, and I have the 5 different approaches. Wherever you see no, it means that there is no blacklisting approach. It means that our network is running default TSCH protocol. Whenever you see a global here, it represents that we do have blacklisting radio channels, but global for the whole network. Label, it means that we have the distributed approach where we have internal collisions. Reordering means that we shuffle the indexes so that the radio channels will be on the same column. So we have the centralized approach, and this is SOTA, means state-of-the-art approach of Mabo TSCH with multiple channel offsets. So if we start, we see that no blacklisting. If we do not use any blacklisting approach, the performance is below any other algorithm when we are applying blacklisting. Then we have the global strategy where we are applying the single radio channel for the whole network, as you can see that it improves somehow the reliability performance, but as you can see, it drops at a certain point, and this is why, because there is a location-dependent features. So if we blacklist globally, there are some corridors, there is some region where these radio channels perform not so good. So this is the indicator not doing global. Then we have the distributed, the label approach. As you can see, it performs proportionally to the number of blacklisted radio channels. So the more we blacklist, the more we use only the good channels, so the more it improves its performance. Then we have the state-of-the-art approach, the MABO TCH. As you can see, it improves for the parts where we have a few channel radio channel blacklists. Why? Because it comes with multiple channel offsets. So if the first channel offset doesn't work, it uses second, third, fourth, and so on. But as you can see, it drops at a certain point. Why? Because if you have too many blacklisted channels, then it will have to use the poorly performed radio channels. So it ends up at the end of the day using, again, the bad radio channels. So it cannot handle large blacklist. So this was the MABO, sorry. And then we have the centralized. As you can see, it solves the problem both of the MABO and the one of the distributed. So there is no collisions, but the problem here is that we have to pay the cost again. And the problem is the converging and the adaptation time of the centralized approach. So the trade-off here that I wanted to yes, so the trade-off here is what I said earlier, that we managed to solve the problem of the external interference and by using only the good radio channels, but we have the cost to pay, which is the adaptation to the link quality variations. So it was animation issue. So the takeaway of the first contribution section. Now, in order to provide, as I said, reliable communication in low-power wireless mesh networks, blacklisting strategy demonstrates with the results that it is a good strategy to go for. So there's a cost to pay. The cost here is the network capacity. So the more we blacklist radio channels, the less parallel communication we can have. So we reduce our throughput. Now, here I would like to acknowledge that this work has been done during the PhD period of Vasilis Kotsiou. Now, the second part of the contribution section is regarding the multipath strategies. We are now at the Ripple routing protocol and the 6-dish protocol stack. And I will start again with the problem formulation. So let's consider now that we have this multi-hop topology where S is the source, R is the destination, and the lines here represents the routing path towards the destination. Now the idea is that the node S, the source, will start to transmit its packet toward its parent. And now let's assume that we have a node, for instance the node I, it is crashed or failed, and the link quality around the node I is under heavy interferences. So the problem is that when the node A will try to forward the packet from its child to towards its parent, the result is that this packet will be failed. So now this node will, if it will try to use the default operation of the TSCH protocol, it will try to retransmit this frame over potentially different radio channels, but the problem is that it may still fail if the problem is at the node I. Potentially at the routing layer, we may have operations so that the node A will select another parent so that to forward this packet, but the problem is that we have cost to pay, and this is the latency, because we need time to retransmit all X times, or we need time to find another alternative parent. While doing so, the network reliability fails because we have packet losses, and unnecessarily the network overloads because we have the signaling part at the routing layer. Now, to address the previously presented problem, we tackled with two axes. So the first was with the Pareo functions, which I'm going to show you right now. So Pareo consists of pool of functions that can be employed either commonly or separately, depending the network conditions to take intelligent decisions. Now, there are more functions available, such as forward error correction, constructive interferences, or reordering, but today I will show you the first 5. So, considering again the same topology where S is the source, R is the destination, and the rest 18 nodes are the relay devices. So the first function of the packet transmission consists of S transmitting its packet to its parent A, and at the same time on the left side, as you can see, we have the schedule where a cell is allocated for this communication. Next, we have the arc function where this frame will be repeated if the previously was failed. So we have a second cell allocated in the schedule. The third function is the replication function, where each node transmits its data packet to both its preferred parent and to its alternative parent. And as you can see, we have the third cell in the schedule. Now, regarding the fourth function, considering that we have the wireless medium is broadcast by nature, any neighbor may overhear this transmission. And thus, in this case, when the node S transmits its packet to its parent, potentially node B may overhear this transmission. So as you can see on the left side in the schedule, each transmission has 2 receivers, A and B. Now, in order to avoid the collision at the ACK layer, only the actual receiver will acknowledge this, this frame. Finally, since the replication increased the traffic load in the network due to packet duplication, the packet elimination function should be applied to reduce this unnecessary traffic. To this aim, once a node receives the first packet, it will decline the subsequent ones. So as you can see here, we have the transmission in the red, and the node I will decline if he previously received this packet. So that was the first approach with the pareo functions, and the second axis now is regarding the how a node will select the alternative parent in order to do the replication. To do so, we proposed the common ancestor objective function, and it's a work that we are working at the IETF, and it is already submitted for the ISG for publication. And the idea here is that a possible option will be that to select an alternative parent for a node as the one having common ancestor. And I'm going to explain you what do I mean. Because we have many variations and enhancements on this subject, I will present you mainly the main idea. So let's take an example, again, the same topology, and we will study the use case of the node S, how it will select its alternative parent based on common ancestor. Now, in this case, the node S has its preferred parent based on the Ripple protocol, the node A, while the node A will have its preferred parent, the node I. Now, among all the other candidates for alternative parent for the node S, B, C, D, E, F, as you can see, only the node B has a common ancestor with the node S. Why? Because the node I is a preferred grandparent of S through the node A, and at the same time, node I is a preferred parent of the node B directly. So by having this, common ancestor approach, the node S here will select the node B as its alternative parent. Similarly, the other devices will do the same operation and will find their alternative parent. So we will have the alternative path towards the destination, and by constructing what we call ladder or DNA pattern, where the 2 paths are close to each other. I will show you a few performance evaluation results. So here I have 3 groups of strategies. Single path, where it's, when you see in white color, with several different retransmission numbers. The disjoint pattern, again with different number of retransmissions, and 3P means 3 disjoint paths, and the common ancestor group of strategies. As you can see, in the terms of the reliability, almost all common ancestors achieve very high, above 96% of PDR performance, reliability. And we have the same or similar performance only with 7 retransmissions for the single path, and with disjoint only with 4 and 7 retransmissions. But the problem is the bounded latency, which was our second objective from the very beginning of this work. As you can see, the more you retransmit, the higher is the chances to have variation in the inter-arrival of the packet. So you have variation in the latency, so the jitter performance, while on the other side, with packet elimination and overhearing, we achieve 1, maximum 2 time slots in terms of latency and jitter. Now, regarding the energy consumption, as you can see here, the retransmission has a strong impact in terms of the consumption level. So the more retransmissions they have, the single and the disjoint, the more they consume. While in the case of common ancestor, we are not based on retransmissions, we are based on parallel transmissions. So the cost that we pay here is the more nodes we traverse in the network, the more we consume. The key takeaways that I want you to remember from this section is the following two. First, why we choose the parallel functions and multipath approaches. First, because we want to solve the original problem that I showed you in the very beginning, that the packet cannot arrive to the destination because we have this single path approach. So we solve this problem somehow by having an alternative potentially path towards the destination. But the second question is why we want common ancestor pattern when we are doing multipath strategy. It is because we want to avoid having this partially flooded scenario while achieving more or less exactly the same PDR performance and bounded latency. I would like to give the acknowledgement here. This work was done during the PhD thesis of Tomas Lagos, the postdoc period of Aris Koutsiamanis, and few research interns who really worked hard to achieve some nice results. I will proceed with my third section of this presentation, the ongoing work and the perspectives. So before going there, I would like to give you the overview of my work. So the idea was, and still it is somehow, to achieve reliable and available low-power wireless mesh networks. So to do so, we worked at 3 layers: MAC, resource allocation, and the routing. But today I show you the work that we have been doing at the MAC layer, and the result shows that blacklisting demonstrates promising results. And I show you the distributed and centralized, but we have a few more approaches, like an hybrid one. Then we have the work at the routing layer that I presented you today, that shows that multipath strategies are as well promising to achieve the previously presented ambitions, the objectives, the reliability and availability. So we proposed the common ancestor strategies to specifically select the alternative parent and thus the alternative path towards the destination. And we have the parallel functions that I gave you some examples. The idea was to achieve high network reliability, and we managed to do. Sometimes we even achieved 99.96. Bounded latency, we are having quite promising results here as well. There is a cost to pay, and this is in our case the energy, because we have the replication part, we have the overhearing, so there are multiple cells, time slots active to receive these packets, and of course we have reduced our bandwidth, so this is another cost that we are paying in our work. I would like to show you a few miscellaneous slides. So here are the research results in terms of the radio channel blacklisting technique. So few journals, several conferences, and similarly in terms of the multipath strategy regarding the Ripple, we do have several journals and conferences accepted for this work. Regarding the standardization, we are working, we continue working actively. So we have 5 drafts that are adopted from the IETF working groups. Mainly we are working at the RAW and DetNet working groups. Now, partially or completely, this work have been already presented either for during international conferences or in summer school events. So under either invited talk or as a tutorial. Last but not least, we are part of this work we are presenting as during our courses at EMT Atlantic. We do this part of this course at RENA, and through the Erasmus Plus program, we gave some lectures on this subject at the University of Buenos Aires. Now we are preparing, I hope we will finish soon, the MOOC on IoT communication and networks on this subject always. And so we are doing lab sessions. We are working a lot with Akuja for the emulation part with Contiki operating system. And we do have the hardware open modes and Zolerdia so that our students will work on different hardware. Now, a few slides regarding my ongoing work and perspectives in the area of low-power wireless mesh networks. Now, as I said earlier, to achieve reliable and available properties in low-power wireless mesh networks, we have worked on multipath strategies over distributed routing protocols. So we have the Ripple protocol, which is distributed, but at the same time, we were working on a centralized scheduling. And we had here a mismatch, so we had several issues when we were trying to have a static and centralized schedule over distributed routing protocol. And now the idea is whether or not we should push both protocols towards a centralized entity, both for the routing decisions, the resource allocations, and why not even the radio channel blacklisting decisions if possible. Now, regarding coming back to the Pareo functions, so I already presented you the 5 functions that we have developed, and they are done. We are working still on the adding more functions in this pool of functions. So we have the several proposals regarding the forward error correction. So we are extending this support as well. Next, the idea is that we have the PCE, so path computation element, that is in charge as a controller to compute the routing paths for the whole network. Now the idea is that we would like to separate what it's called and it's defined at the IETF row working group path selection engine. So to focus for the forwarding plane, specifically at the PSE. Now what does it mean actually is that at the PSE, each node locally can perform the Pareo function. So each node will decide locally without going to the PCE whether I should go single path or multipath. It's an example. Huh? So the idea was to separate this long-term path computation with the PCE to compute the routes in the network, and the short-term, the path selection, which is the short-term time scale, and this is the forwarding decisions. Finally, if we can take a step forward, what about targeting rather a modular stack for IoT constrained devices, meaning that where the whole behavior of the node can be programmable. So not only the routing decision or the scheduling, but what if we try to work on the whole protocol stack to have adding some reprogrammable features whenever we want to change only some parts of one schedule, of one layer or functions of one specific protocol. It would be great to have such a feature. So to conclude, I would like to thank all the people with whom I had the opportunity to work, all these great PhD students. So thanks to them, I will be able to present today, the postdoc people, the research interns. There were like many people coming from even Latin America. Today they are PhD students, they are engineers. So thanks to them, we had all these great results. And of course, all my industrial and academic partners. Thank you.
Okay. Thanks a lot, Georgios, for a very great talk and impressive contribution. So we start this part of your defense. It's time for question, not only question, but also discussions.
Please.
With the committee. I give the floor to the reviewer. And because we have time constraint, I suggest that for each reviewer, they will have about 15 minutes to discuss with you, to ask some questions. So I give the floor to Natalie. You start.
So, hi Georgios, hi everyone. Thank you for this nice presentation. And thank you also for your manuscript. I found it very clear and very well written, well organized, and so I think it well illustrates the quality of the work that you have led so far. So congratulations for this. So I have a few questions, of course. Maybe not so much on the very technical part, because, as you know, I have the chance to attend some of your PhD student defense. And so I already had the opportunity to ask my technical question to them. So my question will be more generic, more general, what I'll say. And excuse me, but can you stop going back? I cannot see you moving, and sometimes you just disappear from the screen. Sorry. Okay, so my first question, if I go in chronologically with your slide, will be in your slide 50 when you introduce the testbed with which you are working on. I think it was 50. 50.
50. Yes.
Yeah. Yes, I was wondering about the testbed that you present here. What is the connection with the work you presented deeply in the manuscript and in your presentation? Did you apply Ripple or 6-stitch?
Do you have any specific testbed in mind, or I can select one? So the first, the last.
I'm speaking about the three you mentioned here. So the electric vehicle, the battery pack, and the solar panel.
Yes. So here, these two, I didn't present it in the presentation today, but in the manuscript, it is chapter 4. So we have the opportunity with Guillaume Legal, who did his PhD defense in September. He did many experiments with the open source vehicle here and with the battery pack here of Renault Fluence. So yes, he used devices from Texas Instruments, and he used, for instance, the Contiki OS to run experiments in terms of the routing protocol and for his centralized schedule. And he did, moreover, experiments for radio characterization. So for instance, we have 3 battery packs in this open source vehicle, in the back, in front, and on the bottom. So he put it several devices from Texas, that were given from Texas Instruments, similar to the open modes. And he wants to do some experiments to see if there is any impact or the radio characterization. And similarly, because he is working, well, he used to work in collaboration with Renault, he was doing some experiments when putting the devices inside this battery pack and the battery pack closure was closed, so that to see whether or not the behavior changes when it is open or closed. Because the idea is, if we go, for instance, to the Renault Zoe and we deploy this wireless communication in the battery pack, whether or not the reliability will be above 99 or, let's say, wired-like networking. So yes, we did here experiments. These two are new, so we just deployed them and we have inauguration a few weeks ago. So I hope we will have the time to do some experiments.
Okay, so, but by now, what you really look at is the impact of this device on the fluctuation of the quality of the link, right?
When you say quality of the link, you mean within the vehicles, right?
The radio link between your device.
So yeah, the idea was...
You are,
Please.
just to be sure I understood well, you really focus on what this specific environment in which you deploy your device can influence the characterization of the radio link, right?
So that was in the very beginning. So yes, we did many Guillaume did many, we were helping him actually, many experiments in the beginning for the radio characterization to understand whether or not we have good environment for wireless communication inside the battery pack. And then the idea was, and he did at the end of his PhD actually, this year, he applied his own protocol at the routing layer, a centralized routing protocol, and the resource allocation scheme, and he ran his solution, and it worked. So we have a solution that it worked for an hour. We had the devices running their centralized schedule and routing protocol, and they were updating them.
Okay, thank you. My other question was, if I'm not mistaken, on the slide 134.
Please.
Okay. Yes, and then, you partially answer this question in your future work. So my question was about perspective way. What would be the interest to combine all your contribution, and if there is an interest, is it difficult to do it? So you partially answer it after, but also, what will be, in your opinion, the limitation of this? Because you also, after, in the perspective part, you mentioned that you will have, in some part, more a distributed approach against a centralized approach. And you can play with these two directions, but what for you will be the factor that will make you decide, and what will be the limitation of all this, the interest of combining all this?
So, nice question. The answer is short. I do not know what will be the result. So the approach that we are taking it is because we have promising results today, and today the result shows that if we are having, for instance, centralized blacklisting approach, the performance is way better than the distributed one because we avoid the internal collisions. Similarly, we see that we have, in terms of the resource allocation, if we go, well, it is in the chapter 4 of my manuscript, right? I didn't have the time to show today. If you see, if we are going for distributed scenario with a 6P and MSF, it takes a lot of time to converge. So the idea is, let's try a centralized so that I hope, and hopefully we will see if it's reduced this time or not. And that's why I said in this slide, that's why I said in this slide, I would love to see the results if we have for all three layers a centralized approach to see if it works and if it is better or not, because I have seen how it works for distributed. Of course, it works, but it is not suitable today for what we are targeting for, meaning reliability, well, ultra high reliability and bounded latency. So I hope that at the end of the day, we may manage to somehow be close or to achieve this objective. And I hope that we are in the right path. So I hope that we are going there, right? I mean, I haven't done it yet, so we are working on it.
Okay, but I guess that you cannot apply your centralized approach with any kind of networks. I mean, if it's too big, too deep, it will induce some latency just to give the instruction compute in a centralized way, or in terms of you may have too much overhead.
Yes,
no?
yes. I had here another line, what about large scale? I removed it at the end. So it is true what you're saying. I totally agree with you. There are approaches to have hybrid version, like centralized at the high level, distributed, I mean, in the local scale. But then what I tried to answer this question was, what about trying this approach? Meaning, what will be the result if we split the decisions for the routing path, which takes a lot of time to compute the paths, with the PSE approach, where we will have local decisions, so we will not dependent from the controller. So I hope, we are working on it, right? So I hope that if we split these decisions of routing plane and the forwarding plane, that we will be able somehow to mitigate the large-scale deployments. So yeah, but I agree with you that there is an issue with large-scale deployments. I agree with you.
Yes, I think you should, when doing so, you should somehow characterize the network that you target and to say, okay, for this kind of network, it will be more appropriate to have this approach, and for this other kind, maybe another approach, based on the density of node and maybe the diameter of the network. I don't know. Okay. And I think I don't have a lot of time remaining, so my last question will be, can you give us your feedback about experimentation, what it brings to you? Is it really valuable compared to only simulation? Do you need both, or only one is enough?
Yes, I think the answer for this question can be in this slide. So, I mean, when Vasilis was doing the experiments with two devices located always randomly in these 6 corridors in the Grenoble site, if he didn't do, I mean, it took him forever to do these experiments. I mean, it's experiments, right? But if he didn't do that, we wouldn't have these results. So we didn't know that we have areas where the devices perform well, and the other areas they perform badly, and so on. So I think doing experiments, I know that it is time costly for the PhD students or for the postdoc fellows, but it gives us some inputs so that we can base on them and continue with our research. So yes, the answer is yes. We need both.
Thank you. So I'm thinking I will leave the floor, and just a last word. You have a very big, very nice picture on slide 140. And again, congratulations for this work. Thank you.
Which slide? 130?
140 it was. It was a picture of you.
Yeah.
140.
Yeah. It is a recursive picture.
It is thanks to Laurent. It is thanks to Laurent that I decided to put this picture for the book.
Okay, thanks, Natalie. Then we move to Cara. So, Cara, you have 15 minutes for your questions, comments, and so on.
Sure. Thanks a lot, and let me join Natalie in thanking you, Georgios, for your very nice presentation. And I would like also to congratulate you on your work. You have done an impressive amount of work of good quality. So congratulations on that. And then I have a couple of questions. One that you may expect is, let's say, how would you relate your work with, let's say, other approaches that exploit machine learning? As you have done a significant experimental work, and as you said, you are planning to do more in the near future. So whenever you've got lots of data, it might be also interesting to see how different machine learning approaches work. So if you could comment on this.
Yes, thank you for the comment. It's true that I didn't present anything related to machine learning today. I mean, the answer is there are many answers for this question. The first is yes, I am protocol-oriented researcher, so I didn't use much of the machine learning, but I did work here. For instance, I didn't present it to you, but I do have a work, for instance, for the blacklisting technique. We worked with a colleague of mine here with 9 different reinforcement learning algorithms, Thompson sampling and so on, in order to select which channel offset we are going to which channel offset it is the best one, so that the devices will select to transmit the packet. So each device will have, for instance, 4 or 6 different channel offsets. I hope you follow me with the channel offset. So I'm here. So you see here I have only one channel offset allocated per node. So the idea is that what if they have multiple channel offsets? And we have a work where we studied different algorithms of reinforcement learning. It was 9 in total, if I remember well. And the results show that, yes, with Thompson sampling, we do have good results, better than without machine learning algorithm. So yes, it is something that I'm considering it. Regarding the resource allocation, it's true that we didn't work yet with machine learning algorithms for the moment, but it is, why not? I mean, it is not that I don't like machine learning, it is that I didn't have the time to include as well machine learning in my algorithms. I'm just trying to think out loud if there are more works.
Yeah, no, I mean,
yes.
Just for the sake of discussion, picking up from what Natalie also said, that is maybe depending on the type of environment, the type of network that you have, and perhaps also the type of devices that are composing the network, you may have different behaviors. So machine learning in this case could help to make decisions that let's say, adapt well to different contexts, to different scenarios, and indeed account for the variability of the environment and the devices that compose the network. So,
yeah.
As you may know, there is this, let's say, initiative that is actually regarding mostly cellular networks, so it's not, of course, related to that. It's the ORAN forum that has produced some specifications, and essentially they conceive the radio as fully automated and driven by these machine learning models and decisions made through machine learning approaches. So I'm not, let's say, in favor of applying machine learning everywhere, of course. I mean, and you are totally right that other approaches may work even better. But sometimes when the diversity is very high, then machine learning can provide you at least with some guidelines on how to tune certain parameters or configuration. So it might be interesting to explore.
So 2 points, maybe 2 points, maybe I can say. Here is the paper I didn't have the time to present you, so where we tried with reinforcement learning to select the best channel offset. And we do have a PhD student that will start quite soon, where we will consider machine learning, and the idea will be how to select the proper metrics. So today we did everything based on the PDR performance. Now the idea will be, instead of doing reactive, but to do proactive at the physical layer. So to use RSSI and maybe other metrics in order to see, first of all, what is the source of this the interference, if it's a Wi-Fi, if it's a Bluetooth, microwave, and so on. And maybe to create what we call the interference map. And based on this, we could get even more intelligent decisions. So this is a funded PhD that will start quite soon between IMT Atlantic and Mid Sweden, Mid Sweden University. I do have it in mind. It's just that I didn't have the time to do everything. It is in my to-do list.
Absolutely. Okay. Thanks a lot. And I was also wondering, since you have been very successful in working, let's say, within European projects and standardization and so on. So now that we have this new horizon, Europe, how would you position your research and the research that you intend to do in the future within this new program framework?
I didn't study much of the European New Horizon, but what I did study is the ERC starting grant. And my work now is, what I'm preparing right now for ERC is this subject actually. The idea will be if it is possible to have rather, in addition to quality of service in the networks today, to add more programmable features. And if it's possible to extend this to more than the classical HDR, the physical layer, SDN, the routing layer, if it is possible to extend this for the whole stack. So the idea is, to add some programmability and modularity in the constrained devices. So this is where I am seeing if it will be accepted, hopefully, for the upcoming 3 to 5 years. So I hope I will finish soon with splitting the PCE with PSC, and hopefully next will be this subject.
Okay, thanks. Yeah, indeed, I think this is a very interesting direction that it's worthy to be. And going back to the test bed that also Natalie commented upon. Just out of curiosity, I know that you are, working on that. But just to understand a little bit better the application related to vehicles. So how would everything be combined? And by everything, I mean the different aspects that you presented today in the test, but looking at this specific application.
So this is work in progress. So we do have a PhD candidate. I mean, we used to have 2, now Guillaume is finished. So working with Renault. So the idea is very specific. So we have the battery pack of, I have to look there. So we have the battery pack of Renault Zoe, which is in the floor of the car here, more specifically. So this is the battery pack. And the idea is that this battery is split in different groups of cells. And these groups of cells, they are having cables and to send this information of the state of health, state of charge for each of their cells every 100 milliseconds, for instance, to the battery management system. Now, the question that they are posing at Renault is whether or not we could remove these, the cables and to do this communication through wirelessly, actually. And we have several proposals so far, mainly at the resource allocation with centralized entity, because we have not so big network. So the network is more or less 12 or 16 nodes, and to send this information within very bounded latency. So this is our target. So we have the TSCH that is running there. On top, we have the centralized scheduler with centralized routing protocol for the moment. Well, one Guillaume did with routing protocol, the other guy is doing star topology because we are trying to see whether or not routing is necessary in such topologies. So this is more or less to be more precise regarding the application level here.
So I was wondering if if this use case or another use case would actually integrate everything, including the channel blacklisting, all the activities, let's say, the main activities that you have presented today.
So the
all part of them.
Good question. So it's again a matter of time. So for sure we have the centralized resource allocation is there. We have the centralized, well, the Fabian now he doesn't use routing, so he has only resource allocation and the MAC layer with TSCH. Guillaume had both the routing layer as well, which was centralized. The blacklisting was not integrated. So that's the only layer that they did not try together with the resource allocation and the routing part.
Okay, thank you. Okay, I think I'm done. Thank you so much for answering all my questions.
Thank you so much.
Thanks, Carla. So now we move to the last reviewer, Jadid, also about 15 minutes.
Okay, thank you very much. Can you hear me well?
Yes, Xavi.
Okay, so Georgios, thank you for your presentation and also for the document you shared with us. You are very direct, and this is good because you explain things in the easiest way, and we can appreciate that today in the presentation, but also in the document. So it's a pleasure always to go directly to the meat in what you write and even in your papers. So I followed your work, I follow your work for the last years. And I have several general questions first, and then maybe later we can go to the deeper details. So now you are the position in which you are becoming, or you become a senior researcher, in which you have to guide or decide where the technology, where where the next things that come go. So I'm wondering if you have analyzed and you have studied what is the applicability of these results you are presenting, where they can be applied, how you can transfer this to the industry or to other sectors. Have you thought about it?
Thank you. Very nice question. Even though, as you said, even though I like to do research, I would love that one day all my work will be in a single stack. But unfortunately, there are not such always this opportunity, right? So the thing is that, for instance, these strategies that we did for Ripple, for multipath, can be applied typically for smart grid networks. So there I can see that Ripple, it is one of the de facto routing protocols for the smart grid scenarios, or gas metering, water metering, any metering application. So yes, multipath with Pareo and all these functions that I show you, I do believe that it is a good match there. Now, for instance, if we go back to the subject of the wireless BMS that we are working in parallel quite a lot with the industrial partners, unfortunately, I'm not sure if Ripple, it is necessary to be applied in such vehicles. Maybe star topology, it is, if it works, why to make complex things? So what I'm trying to say here is that if it is not, even though I would love to have my research to be applied in more realistic applications, but sometimes it is not necessary because we can go directly with a star topology, for example, in this use case, and with resource allocation and simple TSCH or TSCH-like protocol. Now, if it is the protocol TSCH to be applied in the industrial use case, I do not know. From my experience speaking from the industrial partners, it is, even though everybody promote it, in terms of the research community I'm talking about, from my experience when I'm having point-to-point discussions with the industrials, they do have their own proprietary adapted TSCH protocol. So I have to be part of the industrial to have more information because, of course, I don't have all the information, right? There's a curtains for the inside information. But this is what I want to say is that some of the protocols can go for smart grid, for instance, to conclude my answer, and some of them, if I'm going to the subject for wireless BMS, I think TSCH with a centralized resource allocation will be enough.
Okay, I think this is very relevant what you say in the sense that there are industries that they showed some interest on TSCH technologies. Some of them, and also I know that are using some flavors of TSCH networks, but it seems that the standard is not being widely adopted as far as academics and in the academic world we know. So could you guess, or could you maybe focus on understanding why, and if these limitations are because of technological problems, maybe then focus your research on improving that?
Nice question,
How
Charlie.
do you see this?
Nice question. I was, by preparing to be honest with you, by preparing it's a trade-off, right? Something you will win, something you lose. Meaning, if I go with the research that I want to do because I like it and it is interesting for me, then of course I will be a little bit far from the real environment and the industrial zone. But from my experience, the more I go and I work with industrial, for instance, having a PhD with industrial partner, the more constraints I have because they impose what they want to study. Why I came to this example, it is because while we were preparing the MOOC, while we are preparing the MOOC, I mean, I had the opportunity to talk with several industrials, and actually the protocols and the standard that I'm working for the last 5-6 years, I realized that it is not, even though we are promoting them, we are like doing so many conferences, papers, travels, and so on, I see that actually they are not using them. So the industrials come, they push the ideas for the standardization, and then I see that MSF, I didn't find yet who is using MSF. So I would love to understand why it is not used. So to do so, of course, I need to have even more interactions with the industrial partners. But I see that, for instance, on the other hand, 6LoWPAN is widely adopted in the industrial applications. So I found quite a lot of industrials who are using 6LoWPAN, partially or complete 6LoWPAN. And then I see in the routing layer, we do have these two, Ripple and AUDV, that they are both of them really adopted, and I can talk to industrials directly, and they will tell me, to what extent they have extent to, they cannot share everything, of course, their experience with me. So, as I said, I mean, if I will do what I like, I will continue doing my research to improving things that are academically and are accepted, but if I go to work purely with industrials, so then I will be constrained myself, so I would like to have this balance between these two worlds, so that at the end of the day, I would like to have fun as well when what I'm doing, right? Not only running behind the industrials.
Yes, it's a trade-off, I guess.
Exactly, yeah, I want to enjoy
It's a trade-off.
Yes.
Yeah, so maybe you think 6LoWPAN is widely adopted. I agree with you, it's quite adopted. But I think it is that the fact that MSF is not adopted can be more a matter of time. It's a very new standard, so let's see in the years to come.
I hope so.
What I think is important is that from the academia and from the research and experimentation, we provide results that show that these technologies can improve alternatives that are already existing. So maybe to complement what Carla asked you about Horizon Europe projects, I think now as getting to this point in your career is good. You have this focus on funding your research, on building not alone but together with other relevant players in your scenario, in your technology, in your area of expertise. So have you identified, or do you know the groups around Europe that work in the line you are working? And are you aware of European projects or initiatives that will or are able to fund your research?
I will be 100% honest with you. I submitted this year an H2020 project, but it was not 100% close to my subject. So it was rather IoT towards cloud and edge story. So I try not to focus much this year, especially because I had the HDR to prepare, and because this slide, what I'm showing here, it is because I'm working on it for the ERC starting grant. So I hope once I will finish with this story in January, I will start focusing more on the H2020 with more, to see what is the state of the art and to be more with the other groups. But to long story short, this slide here, it is a subject that we submitted for ANR, so National French Consortium with industrial partners here. And this subject here, it is at the ERC that I'm working on it to submit. And in the same time, yes, I'm participating in H2020 project submission. But as I said, it is on IoT edge cloud stuff.
Okay, that's good. So maybe if I move, I have two short technical questions related to RAW and Pareo functions.
Yes.
Have you thought, or have you ideas, or have you considered, maybe as a future work, to evaluate the impact of Pareo functions into the higher layer, for example, into the TCP protocol?
No, I haven't. It's a good question. What do you have in mind, if I may ask?
So, because at the end, Pareo is, for example, replicating at the origin, right? So if you have one source with one IP address, but then you are replicating at the receiver side, you have a problem, or you may have a problem because you can have two different IP addresses as a source. So this requires some paneling, some management of this, let's say, underlying network. And of course, this will introduce some overhead, especially for TCP connections. So I think this opens, I guess, certain research directions that I was wondering whether you have explored or you thought about.
No, I haven't. I haven't because, I mean, I was working mainly at the UDP layer here, so I didn't, but it's a really nice question, and I haven't. And to be honest with you, I want to find my time to see the Pareo functions at the DetNet, to see how they are doing exactly for the wired networks. Maybe there I will have more information regarding what they do with the transport protocols, because to be honest, here we are working here routing and below. And
I think it's still an open issue as far as I know. So really, it's something that it's relevant.
It's a great question. It's a great question. Honestly, I will have a look if this is not it.
Maybe as a final question, also related to the PSE or the path selection engine, and also this management that you require, or the signaling you require to keep this topology, or to keep this, let's say, framework observing the network. What are the alternatives for the signaling? Have you considered different ways to extract the information related to the performance of the network, and then use it in the PSE?
Using the?
And then use it in the path selection engine.
Oh.
So I'm thinking of decentralized information collection versus centralized information collection to take the decisions at the path selection engine.
Yeah, there is this, I think you're talking about the OAM part, right?
Yes.
It is true that there is a cost to pay there at the OAM to maintain and to have all this. There are these passive and more active ways of doing this monitoring. I mean, so far I have done only the theoretical part with the OAM part, so the rules behind it. I haven't estimated the cost. Even I haven't we didn't work really at the implementation part to see what is the cost to pay and which one is the trade-off between these two. Why? Because we didn't finish yet the actual work that we are doing here. I mean, things are working, but they are not final. I mean, we have promising results. So I believe that once I have a good picture of the network and to see if this works, maybe then I will go, I mean, I hope I will have the funding as well to study whether or not how we can to do distributed or centralized or hybrid way for the OEM part.
Okay, I think that's relevant also for the ITF RAW working group.
Yes.
I think that's something, it's good to follow. And I don't have any other question. Just to congratulate you for this large and productive career, and wish you that you follow on that direction and keep going as hard as you have been done till today.
Thank you so much, Xavi.
You're welcome.
Thanks, Javi. Once again, thanks, Natalie, Carla, and Javi for the questions. So now we move to the examiner. We start with Martin. 10 to 15 minutes or so.
Yes, thank you. Thank you so much. So congratulations for this amazing work you presented. But I think there's a kind of an elephant in the room that you haven't addressed, which is, I think, signaling overhead, control traffic, and general channel utilization. If you start with TSCH, you're going to use only a portion of the slots, the time slots. So you lose time. Then you've got to control the attribute, the slots and everything. And I don't think you mentioned that very often in your manuscript. You didn't talk about it today, so I think we need to have a word about it. I'm sorry, it may be a dirty question.
I mean, there is a cost to pay, right? So what you want to say is that the TSCH, it's costly protocol, right?
Oh, for sure.
I know that you don't like it, right?
Is it worth it? I mean, it's extraordinarily costly, it's extraordinarily complicated for what it does.
Yeah, I remember that. Yeah.
You know, do you have any idea? Is it worth it?
I do not know. I do not know why, because I see that more and more, well, not more and more. I see that the industrials that I have interacted with, they are not using it, so they are using today's CSMA. So today I do not know. Maybe in 5 to 10 years, things will change, and they will use it. And an interesting part that I would like to mention is that it is not so bad as we think, or I mean. Why? Because there's a TSCH, which is the MAC layer protocol, right? But if you change, so this is what we did here. So here, when we did some experiments, so we took BLE physical layer, so we have 3 milliseconds for the time slot, and we added TSCH on top of BLE, and then you had like some magic. So you reduced this time of this enormous time of 300 milliseconds, 1000 milliseconds, to something very small, and within 3 milliseconds, you could do transmission and the reception.
You have a point, but you're not really, this is not so much an argument for TSH, it's more like an argument against 802.15.4, which is, pointless because it does,
15.4, you mean the physical layer or you mean the MAC layer?
The physical layer of
Okay.
15.4. It does a spread spectrum, but there's no point, really, it doesn't benefit from it. But because you do spread spectrum, you have very few channels. So I think if you're going to do TSCH or kind of, this kind of frequency hopping, go for a technology where you've got many channels for the stuff.
Yes, that's why I said that.
That's a good point, but it's not really an argument for TSCH. It's more like.
I agree with you that we had this discussion with many partners. It's not by chance that they are not using it, right? I mean, they do use it, but with CSMA. So it's like 2 parts. Like I have 15.4 MAC layer and the physical layer. So if they do MAC layer CSMA CA, they are happy and they are using it with 6-LoWPAN stack.
Yes.
Without the 60s. So with a 6-LoWPAN. But if you take the TSCH, putting on top this physical layer, then they are not so happy because there's complexity behind. But now if you take out this physical layer and you put BLE, for example, you have very powerful technology.
Yes.
I do not know where we can use it. This is a candidate. Maybe there are more candidates. But the TSCH, the concept, it is not by chance that 5G is using the scheduling part. There are many technologies that are using these schedules.
Yeah, the point is, on top of 15.4, it's definitely not a good idea. Another thing was, it was, I think, but this is a conversation we already had. If you go to slide, I think, 82, we see that the less channels you use, the better it is.
Yes.
And again, why do we not have a bar for one channel? Because that would be the best. I mean, if you're going to use 3 channels, you know that you're using the best channel on 2 channels that are not as good.
Yes and no. It's a trade-off. Yes and no. If you have ultra low traffic in the application layer and you have only one single channel,
it could be a different channel from one hop to the next.
I didn't get
And
you.
you could have parallel communications
From
one node to another, and then at the same, on different channels.
But you want.
But you could have only for a given destination, you could only use one channel from one source. So every time for every transmission, for every pair of nodes, you could have the good channel and use only that one.
Yes, I totally agree with you.
List of one, right?
Yes and no. I mean, it's depending.
Per receiver, per pair.
I mean, I don't like to say I don't like to have Bible, right? I mean, it's.
No, it's just like I see this trend. I see this trend on this graph.
So if you see this graph, then if you have only one channel, there is no guarantee that this channel will not drop.
Not one channel for everyone.
But you said one channel per pair.
Yeah.
Voila. So if you go per pair, there is no guarantee that this channel for this pair allocated will have always 100%.
Yes, for sure. You need to adapt. You need to make everything. But I'm just saying that on the graph.
So at the end of the day, somehow you are doing some adaptation. So it is not as fast channel hopping, but somehow you adapt yourself. So you want to adapt, right? You don't want to take like static. I want always channel 16.
You need to adapt.
Okay.
But then I'm just saying on the graph, I see 9, 6, 3, and it's always better. When the whitelist is shorter, it is smaller. It's always better. Unless it doesn't work or it's within the error bar, so you cannot conclude. But the only time where it's really better is for only 3 channels.
Let's not forget that we have a specific size here and specific traffic. But if you increase the size of the network and if you increase the traffic, you cannot have these results.
I don't know.
Yes, why not?
Yeah,
I mean, because I pay the cost, it means that I cannot have as much traffic I want when I'm here, for instance, in the green line. Do you agree with me, right?
No, not quite, because if you whitelist is one you could still schedule and become when it will work. Well, we can take
no, but it's a good question. If you have a dense network with many devices in the same area, then somehow you limit your parallel transmissions if you don't have enough channels to transmit these pairs.
I see. Yeah, when you build the schedule, then it becomes complicated.
Thank you.
Yeah. Okay, that's fine. We can. Do you have time for?
Yeah, a few minutes.
Maybe something I misunderstood a little bit, but you were talking about, in the Pario section, you were talking about duplicating packets. You duplicate and you use overhearing to take a duplication decision, right?
Yes.
So this is all based on overhearing.
Yes.
How can you hear the traffic from other nodes in the TSCH context where you could be on another channel at the same time?
So that's why I'm saying that it's a good question. We are somehow doing centralized hacking, meaning that we enforce that this device
is scheduled
yes.
and knows that
Yes.
it has to.
Yes, so we have, that's why I said in the beginning, at the end, I have this mismatch between routing and the schedule. So we have a centralized schedule, and this is the disadvantage that we pay here, that we have these two guys to listen over the same channel.
Yeah, and the idea is to maybe get rid of the
Yes.
RPL, which is also a good idea.
Yes. You don't like RPL either, right?
And that's saying it.
Shall we discuss RPL or?
No. Don't get me started on that.
You don't like networks, right?
No. I look. That's the point.
No, it's a joke. No, but yeah, yes, we force.
I'm sorry, this is going to be, the next one is out of curiosity.
Yes.
In the BMS section, in the manuscript,
BMS?
in the battery management system.
In the manuscript?
Yeah, in the manuscript, there's kind of, this may be hard. When you describe the routing that you want, the routing problem in the battery.
The constraints?
Yeah, the constraints. The way you optimize, there's you want to maximize kind of the probability of receiving the packets at the route, at the destination.
Yeah.
And then there's a variable k at 1.1 bird.
I don't remember by heart, but yes.
You don't remember? I guess that's going to be too complicated with the slides, so we can discuss this.
Okay.
This will take forever. And it was kind of my curiosity that was triggered by this. This is not very important. So let's do that. So thank you very much.
Thank you. Welcome.
Congratulations again.
Thank you.
Thanks, Marco.
Marcelo, next question.
This is Alves. Thank you, Georgios, for the invitation and for your presentation. The work very nice. I always learn a lot from what to do. I did when I was a member of your physics committee, and they are very interesting. Congrats for the huge amount of work and contributions you had. The last slide with the list of collaborators and students was impressive. So it's difficult to make comments on your career. So it's a very positive point. I have a couple of questions, but at least will come from me to have to select some of them. You had a few discussions during this question and answers section about the adoption and the of this TCSH solution and by industry, whatever. My question is a bit in the time scale a bit earlier than that. Because you present in your manuscript and in your slides, this as the starting point, but it's not really discuss what's the motivation that you have to take this as the starting point of your work. Why not another one? I was just curious about that.
Yeah,
Well, like taken for granted. Is it because it's IEEE you did not ask yourself about what would have been other alternatives, or?
it's a good question. I guess somehow there are it's a multi-parameter decision, right? So you were in my PhD committee. So at that time, I was having 15.4, but it was not TSCH, it was CSMA-CA at that time. So my PhD was pure CSMA-CA, and I was doing 3 years of how to improve CSMA-CA. Yeah. So I found it somehow like I have not much to give for CSMA-CA, and now we have TSCH somehow performs better in terms of there's a trade-off, of course. So and it was exactly the timing when these guys started doing with MSF and 6P. So it was really when I was finishing my PhD that started this work on TSCH, and like I went to Bristol University. People there were focusing on TSCH, so it was somehow like, why not? I mean, let's try.
Okay.
So I came here to Rennes. They were working on TSCH as well. So somehow like, and I liked it. I mean, it's not spotted protocol, right? I mean,
Okay. Oh, good.
so it was somehow like
Okay.
I saw that evolution, but I expanded myself. So then I started working a lot with Ripple. Then I worked a lot on 6LoWPAN with compression. I did many work on the fragment forwarding, stuff like that. So I think it was natural for me to. I mean, it's a good question, but it was natural to me to think directly this stack because I was working for since 2012 on this stack from different layers. But today I'm working in multiple layers over the stack. So that's why.
Good. So opportunities are pushed in this direction. So
I can say that.
That's
Yes.
very fine. Okay. I don't remember the number of the slide, but you have this plot. You made some measurements with very good channels, very good ones, and one that goes up and down.
Yes.
So this one, yes. So can you remind us about the conditions under which you made this experiment? So should I expect that in another day, in another situation, channel, I don't know which one is very good because you have a few of them there, maybe 17 is very good, and if I change the location and the day, 17 will be the worst one, or you can have some kind of patterns of these channels throughout different scenarios for some reason. I don't know, I'm just raising the question.
It's a really good question. So the answer from the very beginning is no, I do not know, because I cannot predict the environment. I mean, I will open and I close the door, somebody will come with his smartphone and will change the radio spectrum environment. But what can I say is that the results show that sometimes some of the channels, typically for instance 25, 26, that they are outside of the Wi-Fi interference. So for this channel, I can say that yes, we observed that they perform well. But then we have observed, I mean, even during my PhD period, I saw that these channels 12, 13, 17, 18, they have impact from the Wi-Fi. So this I can say without going into the experiments that there's guarantees, well, if I can say guarantees. But then, this is why we did these experiments, to show that there are some takeaways information to take, that please adapt, don't make fixed. So one of the information that we took is that do not make fixed threshold. If you want to blacklist and you don't put this fixed threshold of 70% or 80%, because the link can go up and then can go down. So make an adaptive threshold that will adapt to the ongoing performance of the link qualities. So this was, for instance, for the threshold. Another one was, please do not, in this case, for instance, blacklist globally. Let the devices to perform their measurements on time and adapt them. I mean, maybe they will perform better or worse. So have adaptive blacklisting method in terms of time, but in terms of the location as well. So, as I said, to conclude, I think to your question, a priori, I can only guarantee for very specific radio channels. I can give you guarantees only for very ultra short distances, but then the rest is agnostic.
Okay, sounds great. Okay. Have you made the question about how to transfer this to industry? 99 client of your technology, and in some, for example, in chapter 4, you have some alternative proposals. If I want to buy your solution, how should I proceed to pick one over another one? What you I don't know, by reading the manuscript and following your presentation, some have pros and cons in one situation, and what would you recommend your client?
Go for chic. Here's the guy, so buy from him.
That's a rough.
To make
the first steps
to make it serious,
the right decision.
you have to come to me and tell me what is your problem. So tell me what is the use case.
You would be able to.
I will help you. I will not guarantee, but I want to know what is your scenario, your environment, open, closed, the size of your network, the device that you are using, whether they are powerful or constrained. I mean, if you will give me inputs, maybe together we can.
Even measurement of external interference would be useful for this kind
Exactly. I think together we can somehow.
Yeah. Okay. Go to slide 134. I guess so. Yeah. 134.
134.
Sorry, I'm focusing some numbers, but
No.
But these are the most interesting aspects.
Please.
Oh, not this one.
134, no?
That numbers. Okay. Sorry, this one. You said achieve very high-end network reliability in some cases, and okay, right in your manuscript, you said somewhere that high end-to-end reliability is not enough. It has to be very high. What's very high? I got lost. Is it very high or high? I don't know.
I do not know. It depends. So it depends the application. So there are some applications that they need really high, like for the wireless BMS, they want to receive this information every 1 or 200 milliseconds, but they want to receive it. So that's why we need to have a protocol that will be very close to the wired. Otherwise, Renault will not accept, right? So this is the simple application. But there are applications, I do not know, LoRa and Smart City that high, I mean, even 99, it's a lot, right? I mean,
so it's
depends.
application driven.
Yes.
Okay.
So I will correct the.
Yes.
So,
yes, there's a sentence that's very strong and
yeah.
gives all the.
Yeah.
Okay, right. And there's a final one. No. Yes, final one. You list a number of topics as future work, and it's still very related to low power wireless mesh networks and some add-ons for right on top. But in the future of this field, with your experience, with all you did, you are an expert in this field. What's the pain point of this kind of networks, even beyond what you do?
So for the specific network or in general?
It could be
So I pick up this slide, but I put it at the end in the backup. I
whatever
didn't.
you want.
It was in the beginning. I was thinking I should put it, and then I didn't have time, so I took it out. So this is subject that I'm working at Beacom with Philip and the postdoc. So we have this integrated access backhaul in the 5G networks today. So basically the idea is that the operators, they are considering to deploy EIB nodes, more EIB nodes to have more denser coverage. And the idea is that they want to avoid having fiber optics here, so to reduce the cost. So they want to have this millimeter wave communication. Now, the idea is that, I mean, we are working on it currently. So we have a multi-hop topology. So this topology resembles quite a lot what I was presenting before. So the idea is that if we could somehow to do minimum of what I did in the low power networks to apply here, it would be already a gain for me to see this technology transfer from one network to another network. Because it's, at the end of the day, I don't care if it's low power, if it's Wi-Fi or 5G. So the idea is that to provide similar performances over different networks.
That's enlarged your area of application of your idea. So thanks a lot. Thanks a lot.
Thank you.
Congrats. Great work.
Thank you. Thank you much.
Thanks.
Thank you. Thank you, Georgios, to invite me to this HDR.
Thank you for accepting.
Three main reasons, because it makes me coming back to work that we did with Kwang and Fan on routing in wireless network. Okay, and it was really interesting, but the objective function was much more on TOE, quality of experience, and the mean score was the objective function in order to maximize it. And we did work on ORSI, so it makes me coming back to these works that is very fun. And now that you finish with your HDR, we can have discussion. This is the first version. The second reason for that is that the document was well written, and I learned a lot. So congratulations for that.
Thank you so much.
And except the part where at least to my on the side, I was so glad to come back to some acronyms. So, but it was very interesting to. So thank you for that. This was the second reason. And the third reason is that this time I'm not the president. So I can be relaxed and ask some questions. So thank you for that. So just a few questions, and regarding the, it will be on the routing aspects.
Please.
And it will be regarding the performance evaluation. As you know, we have a very rich program regarding scalability.
Yes.
When you have the increasing nodes in the wireless network, it deteriorates the performance. When you have also noises in the physical layer, which impacts seriously all the upper layer. So regarding, for example, the retransmission, packet losses, etc. So you have to deal somehow with scalability. So what I read on your document is that you have evaluated 6 routing algorithms, including the on-demand selection algorithm that you proposed.
Yes.
Okay. And for that, you did 20 simulations.
On demand doesn't mean AODV, huh?
ODC.
We agree that on demand it is our proposal, it doesn't mean AODV.
Okay. Okay. And you have said that you use a total of 5,000 packets sent for each routing algorithm.
Yes.
So I don't have idea about the simulation parameters of other works in the area.
Yes.
But do you consider that it is enough?
No, I didn't. I didn't.
And what about the stability?
I didn't consider this enough. This is what we did. We had many different configurations before.
Okay.
To be honest, I don't have the slides here, but before we started, like back in 2016, the topology was much more smaller. We were like one source, one destination, and 6 intermediate nodes. So we started really with 8 nodes in total. So we did like few papers, but because it's not so easy to scale up. So then we took like, okay, let's make scale up. Why? Because as I said, we have a static schedule. So this is our main constraint. The more device we have, this schedule gets huge. Honestly, it's getting really big because we have to keep all these time slots. So we don't have adaptive schedule yet. So this is like work that we did not finish. So this was something that we wanted to work on it, but we didn't have the time. So I don't say that it is enough, but what I can say is that with this setup, we got these results. I'm not sure if it is enough or not. We tried with different quality links. 50% of all the nodes had 50%, which is quite low. And this is it's not randomly selected. It is we read it in white papers of well-known microcontroller enterprise that when they are deploying their devices, they have each device minimum 50% of link quality between them and minimum 3 parents. So, I mean, the setup was quite, we tried to be as realistic. I didn't want to have.
Because if you scale up.
If scale up, I have a problem. I know that. I have a problem because of this.
So another point will be about the overhead of the work.
Here.
The algorithm, because
Yes.
at one time you said that each node will deliver four packets to the preferred and alternative parents, leading to a total of up to 8 attempts towards do that route.
Yes.
So I was wondering about the overhead.
It's a lot. We calculated the overhead. It is a lot. We are.
Did you evaluate it?
Yes, I don't have the results here, but yes, I have. We evaluated in 2018 transaction and industrial informatics paper, and we have huge overhead.
So-
I said this many times that we pay bandwidth and the energy. This is, I accept this.
So you were
We pay-
a kind of trade-off.
It is a trade-off. Yeah. This is something that we study always at the end of the papers.
Yeah.
That yes, we achieve these results, 99 point something, bounded latency of few time slots, but we have the cost. I'm not saying that this is the best, right? It's a trade-off. If you want, we have this. I mean, I hope that we will manage to improve it even more. So that's why we did with Thomas his last work with this blue part, the Odyssey, which I'm quite proud of, because we managed to reduce. I have the figure here at the end. Because we managed to reduce the number. So these slides I didn't show you. It is the number of traversed nodes in the network. So you have the multi-hop network that I showed you before. So each packet through how many devices going through and before arriving to the destination. So we had a problem that they are doing still with these first 3 algorithms. We are having somehow flooding. So they are going outside from these 2 paths. So we worked a lot with Thomas and Aris to make sure that we will keep always, not always, but if we can do, to keep these 2 DNA. So we somehow, I think this is the minimum we can go. We cannot go below than 2 parallel paths.
Works that are trying to, what do you call it, pruning? Yeah, to prune some paths.
Yes.
Do you check about what it can, how it can contribute to
not using some paths?
Yeah.
Yes, so this is what I want to do next. This is the part here, is if one day I can separate the forwarding plane from the routing plane, then each device can decide autonomously whether I'm going to replicate or not. Maybe it's not necessary always to do replication.
Okay.
So this done, I haven't done this, but this is one of the perspectives.
So you say in some part that you will stay working on the schedule functions. That you have 2 PhD that started just last year on the schedule function.
Yes.
But you didn't say the same for the multipath.
I don't have funding.
So does it mean that you'll be stopping this access or?
No, I try to do whatever I can. I mean, no, because I really want to do this part.
Yeah.
This is. I really hope that I will manage to get funding for this as well. I mean, I hope I'm lucky with my NR or I don't know.
Okay. And regarding all the contributions that you provide in your work, which is very important and very large, for example, you work on backlisting and scheduling and also multipath routing techniques. Okay. So, from your point of view, which one appears to you the most innovative and why?
Oh. I mean, if I would, it's not a good idea to select, right? I mean, I would have to be.
This will be the last question.
Yeah, I know, but I don't like selecting things because not everybody will be happy.
So, what is the one that you will say, oh, I'm very proud of it, and I would like to be developed, to be implemented in the industry?
I mean, to be honest with you, and I will be honest because I like to be realistic. All these papers and all these papers, it is not one single paper. There are story behind. So, I mean, I have combination of papers that they extend, and we are, for instance, when I started back, when I arrived here, and we started with this paper, this one, ICC 2017, and it was my really first paper that we see that maybe this can happen something here, but we made many extensions of this paper, so that somehow the Odyssey, the last one, which is the best paper of Thomas, improves essentially and gives really clear paths so that we can do multipath, but we reduce at the same time the flooding. We try to avoid, or I mean, we cannot have 100%, but we manage to avoid. This is for the work of Thomas, and for the work of Vasilis, that I was proud as well of him, is for his last paper for the whitelisting. And this funny story behind is that this reordering part that he did, it was because his profession is teacher as well at school. So he is the one who is doing the timetable for his classes. So the idea of reordering came from his work. So he was trying to find the timetable for these classes.
Which is an NP-hub.
Yes, it is NP complete, yes. So the idea came to him like that. He was doing the program in August for the high school pupils, and he realized that there is the same problem, how to adapt the teachers, the pupils, and the time plus the classrooms. So this reordering came through this idea of, and I find it quite nice because the real life gives you solutions sometimes. Thank you so much for your questions.
Okay, so now we're very close to the end.
Yes.
But before I have some comments and
Yes.
probably 2 or 3 questions. So first, thanks a lot for your invitation. You have a very impressive trajectory since your PhD. It's a very, it's very impressive the way you contribute your work, your methodology, the number of collaboration you have, publications. I have three questions. It's more some advices I need.
Please.
You have a strong involvement, implication in science, and you publish a lot of your work, but also you have a lot of contribution in standardization. You participate to 6 working groups at IETF, and my question is, what do you learn for your science from IETF?
It's a question or a comment?
Yeah, it's a question. It's my question. Is it really important for a scientist to go to IETF? Do you discover new problems, new challenges?
It depends the working group. I will be 100% honest. It depends the working group that you are going. So there are working groups that, I mean, I don't follow everything, right? I mean, I select which working groups I will follow.
Yeah.
So if I see that, I mean, for instance, the role working group, it was really by chance that I started. I mean, it started with role.
Yeah.
So because I started doing this replication work when I arrived to Telecom Bretagne, at the same time, Pascal was doing his thesis here with us on this subject. And people here were, Geraldine, Nicola, they were like involved on this subject. And like I took this, okay, why not? I like it. And I mean, sometimes things happen by chance. And I followed a few times IETF, and I liked it, the community. And then it was the period that 60s working group started, where all these TSCH, MSF things. And you learn from the discussion, you see the problems that there are, you see, I mean, there are most of the times industrials.
Yeah.
So you see there are problems behind. While being in my office, I don't always know what are the problems, I mean, the real problems. So this is the good thing that I liked it. And then the second part is that when something new starts, like the role here, working group, I mean, it's good to be the state of the art. I mean, to see.
And
yeah.
for your PhD students,
Yes.
Do you advise they participate to IETF, to follow the mailing list, to participate? Is it?
It depends the PhD student.
Do you think it is a kind of methodology?
No, it depends from, to be honest, I always select. I see if the PhD student, it is dynamic and curious.
Do you have which are not involved? Take care.
The new one who started 1 month ago, he didn't. No, yeah, I do have. Yeah, there are a few, but I mean, it really depends. There are some students that they can anticipate. Not all of them they can anticipate it.
Okay. I have a second question. During your presentation and during the questions and answer, many often you said there is a cost to pay.
Yes.
There is a cost to pay.
Yes.
There is nothing which is free.
Yes.
As an expert in networking, in wireless networking, what is the cost which is the most complicated to manage or to solve or to deal with? Which is the most complicated one? Because you have different kind of cost. You have the cost of the overhead, the latency, the capacity. You have a lot of costs you have to pay to provide reliability, to manage the jitter, blah, blah, blah. So if you start a PhD thesis with a PhD student, and you say at the beginning of the first day, you say, okay, during your PhD, you have some cost to pay. To solve your problem, you have some cost. Do you have any advice to identify what is the cost which is the most complicated to deal with?
I mean, when I was PhD student, my objective was to minimize the energy consumption. So for 3 years, I was doing this job. Like, I will find the best, I will adapt in the best way the CSMA-CA protocol to minimize the energy consumption. Why? Because the subject of my PhD was this. But now, I mean, I think I said it in the very beginning of my presentation that if we target the applications that the devices are plugged in to power supply, then I don't see that this is a cost, high cost for me to pay. Because the energy is there. But if I'm having a smart city and my devices are, or agricultural fields, the devices are somehow deployed, then the energy for me is a cost that I have to consider. So of course, this work is not for smart cities when I'm having this. But in this case, in the very beginning, I said that if I'm having application that devices are plugged to the energy supply and the traffic is low enough, I can trade this cost. So it depends on the subject of my PhD student. If it is this subject, then yes. If not, I will find another one. I will adapt myself.
And I have a last question.
Yes.
In fact, in networking, there is two kinds of networks. There is wireless networks and cellular networks.
Yes.
And the ideas, the architecture, the protocols are quite different.
Yes.
In 5G, there is something which is quite new, which is very interesting, which is a slicing paradigm.
Okay.
Okay, you know what is a slice?
I do not know by heart, but I know what is the.
So a slice is a part of the cellular network in order to give quality of service support, okay, or to respect quality of service constraints. Regarding to your work, where you try to have some application just the best effort support, and for some application you need reliability. Do you think that this idea of slicing could be applied to wireless mesh networks, wireless networks? It is a question I have. I have no
I-
answer today, but it's a question I have, and really I don't know.
So
I know-
slices is what? It's a
It's
dedicated flow?
So in your presentation, you have some, you said in your perspective, or it was a slide about ongoing and perspective, you said, oh, maybe I can have a controller for routing, scheduling, for blacklisting functions. And also I need modularity for the IoT stack, protocol stack. So if you want to do slides, what does it mean? It means that you have controllers which manage slides. One slice, it's a kind of KPI support, so quality of service functions. It is a part of subset of the resources, subset of the links, subset of the nodes which are on
So it's like flows, like traffic flows.
Yeah.
Yes, so there is this concept. I mean, if I do not know slice, but traffic flows, then I can.
Yeah, it's not exactly the same. Traffic flows and slice is not the same. The slice, the idea of slicing is to say, okay, we build a physical network, and considering this physical cellular network, we provide several logical cellular networks for virtual operator, for instance. Okay, so it means that you have a controller which manages the resources dynamically, according to the user traffic, the user requirement, blah, blah, blah. So my question was only, do you think that this kind of approach could be applied to something else?
I'm trying to understand what you're saying. I mean, I think I understand. I mean, I think I am getting there. Maybe we are a little bit behind in terms, not because of the technology, not because of the protocol, but because of the capacities of the devices. Like, we still have very constrained devices, but I think we are getting there. Like, I mean, if the technology in terms of the hardware will allow us to have strong devices, maybe we can be there. And I mean, the subject that with Mahtan we said, I really like it, is, no, it's a serious. TSCH over BLE and TSCH over 15.4 classic physical layer, it's a huge difference. So if we can have a stronger physical layer, then maybe we can have stronger capacities to do, I mean, why not even slicing? So, you see what I mean?
Yeah, I see.
Okay.
Okay, it's time. So finish for the presentation and discussion. So now we move to the private discussion. Okay, so I guess that we leave the room.
Yes.
We have a dedicated room.
Yes, it is 111, I will show you.
Natalie, Javi, and Carla, I sent to you last Friday a link using Zoom for the private discussion. Can you move to Zoom and we will be connected in a few minutes?
Sure, thanks.
Thanks.
Okay, move there, thanks.
Cette réunion n'est plus enregistrée.
Vous avez envie de dire depuis tout à l'heure.
picture about his impressive professional trajectory. He presented his main contributions on channel blacklisting mechanism to avoid the use of poor channels, and his work about multipath reliable routing. At all times, he followed a strong and thorough methodology. Firstly, to start with a deep analysis, including experimental characterizations. Secondly, to use simulation to evaluate his contributions. And finally, to validate his proposed solutions to the real world through experimentation on testbed or real environments. Simultaneously with his research activities and standardization efforts, Georgios was involved in the supervision of numerous master and bachelor students and young researchers. He also got strongly involved in the teaching department and took administrative responsibilities. We highly appreciate his attitude towards innovative teaching activity like the MOOC. The committee highlights the impressive amount and quality of the research done by Georgios, not only published in top-notch journals and conferences, but also within the IETF standardization body. To the numerous questions of the committee, Georgios gave precise and straight-to-the-point answers. He demonstrated his mastering of the domain and his ability to identify innovative research directions. We are convinced that these research directions will draw significant interest both from academia and industry. From his answers, it is clear that Georgios is aware of the framework in which he will further develop his career. For all these reasons, the committee agrees to deliver the habilitation à diriger de recherche of the University of Rennes 1.
Thank you. I mean, the report is impressive. I mean, I cannot. Thank you for it. I mean, it's really, I appreciate it. I really, it's have nothing to say. It's impressive. I mean, thank you so much. I mean, I'm happy that you like the report. I'm happy that you like the presentation. Thank you for coming here. I mean, I know that's not so easy for you. Thank you in distance for your reviews. Thank you for your encouraging reports. Thank you for your questions. Thank you for accepting being in this jury. I mean, it means a lot to me. I mean, yeah, I mean, I know most of you like for years since my PhD, and I'm really happy that you're still here and we are continuing doing this. It's important for me. I mean, it's a nice community. I like it. I love it. Thank you, Xavi, for always being there whenever I knock the door, and Natalie. Carla, nice to meet you, or in distance. I hope I will see you one day in person as well. I mean, this work, again, it's because of my PhD students and my postdoc fellows, and of course, the research interns. I mean, it's all together separately. We did something, I hope, worth mentioning and worth presenting today. Many thanks to my colleagues. Thank you for helping me. I mean, it's... in daily life, collaboration in research, teaching, writing proposals, drinking beers. I mean, everything is important. I mean, thank you, Pascal. Thank you, Pascal. I mean, we have been working together for so long. I'm happy to have you on board. I'm happy to work with you. Happy with all my industrial partners. Nice community, nice people, nice friends. Thank you all for being here. Thank you, Eugenia, for being there always for me. I mean, at home and helping me. I mean, even listening to my presentations for rehearsal. Thank you, my friends. Thank you for coming. Thank you all. We have nice po. It's a Greek po today. The Camion Grec came, so we have special po for you. So I hope you will enjoy it. I mean, thank you. Thank you, Natalie. Thank you, Xavi. Thank you, Carla.
Bye. Congratulations again.
Congratulations, Georgios.